Welcome back to this explainer by Forge College. Look, if you're joining us today, it means you actually survived our last lesson on the Solana CLI without, completely throwing your keyboard out the window. So congrats on that. Today, we're taking a massive leap forward. We're drafting the blueprints for a secure local digital vault so you can finally start signing real transactions. Let's just jump right into it.
Okay, so let's get into an absolutely crucial distinction right off the bat. In our previous lesson, we were really just poking around with unsigned queries. You can think of unsigned actions like reading a public bulletin board. Literally anyone can walk up and check the cluster status. But if you want to cross the bridge into doing things like airdropping SOL to yourself or actually deploying your very own programs, you need a VIP pass. In the Solana ecosystem, that VIP pass is your local key pair. That's what allows you to execute signed actions.
Here's our engineering blueprint for today's explainer section. Section 1, the local wallet bridge. Section 2, setting up your workspace. Section 3, forging your key pair. Section 4, locking down permissions. Section 5, verifying the setup. And Section 6, your wallet flow artifact. Let's get building.
Section 1, the local wallet bridge, crossing into signed actions.
Now, you might be sitting there wondering, why do we even need to bother with this step right now? Well, the answer is incredibly straightforward. Every single signed operation on Solana requires a local key pair file. I mean, you can't just walk up to a validator and say, hey, trust me, bro, when you're deploying a program. You have to definitively prove who you are. The CLI relies entirely on its ability to reference this specific local file to authenticate you. And the core tech behind all that authentication? It's called 82.55519. Now, don't let the cryptography intimidate you. While the math behind it is definitely brilliant, for our purposes as developers, an 82.55519 key pair is essentially just a standard digital lock and key. It's an asymmetric key pair used to prove you own an account. The public key is the lock you show the world, and the private key, that's the unique key only you hold to open it.
Section 2, setting up your workspace. Blueprinting the vault.
Okay, before you go generating any sensitive files, we need a dedicated, safe space to keep it. We want it far away from any unrelated configuration files. Think of this like a pristine vault, definitely not your desktop's new folder 3 graveyard. So we start with two completely safe local file system operations. First, mkdir-p creates a dedicated directory. We're using Solana dev/keys in your home folder here. Then cd just switches you right into it. Trust me, maintaining a clean, organized directory structure from day one is going to save you massive headaches when you start managing multiple projects later on.
Now listen up, because the CLI can be pretty sneaky here. If you aren't paying close attention, it's going to hide your files in its own default locations. For instance, if you just create a key pair without specifying a path, boom, the CLI drops it right in your current working directory. Or if you don't update your configuration, it might default to a global hidden file like /solana/id. By explicitly understanding how this works, you take control back. When you run commands that sign, they automatically use the configured path shown by Solana config get, unless you override it, of course. The golden rule, we want to be explicit, absolutely never implicit with our keys.
Section 3, forging your key pair, manufacturing the key.
All right, here's the exact command to make the magic happen. Running Solana CLI new tells the CLI to generate a fresh ed25519 key pair. Notice that -out flag? We're explicitly telling it to drop the file right into that secure directory we just created, and we're naming it dev key pair. We're also throwing in the -nobip39 passphrase flag. This just skips adding a mnemonic passphrase. Look, for local development, typing a password every single time you compile and test is just an absolute nightmare, so we intentionally skip it here for convenience. But, and this is a massive but, here is the absolute crucial takeaway. By skipping that passphrase, your key file is now unencrypted plain text sitting on your hard drive. Even though this is strictly for local dev and local test networks, you really have to build good habits right now. Treating unencrypted files casually is literally exactly like leaving your physical house key resting openly, right under the doormat. It's basically an open invitation for trouble. Section 4, locking down permissions, securing the perimeter. Since we definitely don't want snooping roommates, malware, or random background software digging into your newly forged unencrypted key, we have to secure the perimeter immediately. Running the Unix command chmod 600 against your new key pair file is, well, it's like slapping a titanium deadbolt on the door. That number, 600, means that only you, the specific owner of the file, can read or write to it. It is entirely locked off from the rest of the world.
Section 5. Verifying the setup. Quality assurance.
So, we've built the vault, we manufactured the key, and we locked the door. But good engineering always requires quality assurance. Let's see how we build a complete verification loop. First up, you run solana keygen pubkey pointing at your new file. This safely reads out your public address, proving the file is valid and isn't corrupted. Second, you run solana config set-keypair with your path. This basically tells the CLI, and here's the direct translation. Hey, from now on, use this specific VIP badge when I ask you to do something. Finally, solana config get acts as your visual confirmation. It prints out the current setup so you can verify the CLI actually updated its internal configuration to point directly to your new keypair.
Section 6. Your wallet flow artifact, the engineering logbook. Because we aren't just firing commands off into the void here, we are creating what we call a wallet flow. Think of your wallet flow as your personal engineering logbook. It's a living document that proves you have a reproducible, completely secure process for managing keys. Look, when you're knee-deep in testing and suddenly your transactions start failing because of some weird authentication error, this logbook is the very first thing you're going to check to make sure your environment is pointing exactly where you think it is. Take it from me, you will be so glad you have it.
So what actually goes into this logbook? Precision, basically. It should list the exact file name and path of your key pair. You need a copy-paste of your creation command and the public key it originally spit out. It should show the output of your pubkey command, so you can absolutely prove they match up. It should include the ls-l terminal output, proving you successfully applied those 600 permissions. And finally, it needs the config get output, showing the CLI is wired up perfectly. I highly recommend actually pasting these terminal outputs right into a text file. Hit every single one of these criteria before you even think about moving on.
You know, you've built the vault, forged the key, locked it all down, and logged your work. You officially hold the keys to your local cluster. The only real question left is, now that you have the absolute power to sign transactions and alter the blockchain, what groundbreaking program are you going to deploy first? Keep that wallet flow document super handy because in our next explainer, we are putting it to work. To explore more on this and dive way deeper into Web3, make sure to visit forge.college. I'll see you in the next explainer.